All right, let's pull back the curtain on one of the coolest procedures in aviation. We're stepping onto the flight deck of a Boeing 737, one of the most common airplanes you'll ever fly on. And we're going to break down exactly how pilots take this incredible machine from completely silent and dark to roaring and ready for takeoff.
You know that feeling, right? You're in your seat, you hear some clicks, some whirring noises, and then, eventually, that amazing roar of the engines. But what is actually going on up front in the cockpit? Well, let me tell you, it's so much more than just turning a key. It's a carefully choreographed dance where every single step is absolutely critical.
The pilots start with what they call a cold and dark cockpit. And they mean it. Nothing is on. No screens, no lights, nothing. It's completely lifeless. And from this state, they begin a methodical journey, following a very specific checklist that makes sure every switch, every system, and every warning light is working perfectly before they even think about leaving the gate.
So, first things first, how do you wake up a sleeping giant like this? Well, you can't. Not on its own, anyway. The very first step is giving it a jolt of electricity from the outside.
Think of it like plugging in a giant, very complicated appliance. A ground power unit, a GPU, gets hooked up to the plane. Then, inside the cockpit, the pilot flips one simple switch that says GRD power to on. And boom, just like that, the cockpit flickers to life. The screens light up and the whole process has officially begun.
Okay, we have got power. Now the real work can start. Before they do anything else, pilots run through a whole battery of super important safety tests. It's kind of like an orchestra warming up, but instead of violins and trumpets, they're checking every alarm, every warning, and every emergency system on the plane.
And this right here shows you just how serious these tests are. The pilots actually have to call the ground crew and warn them, hey, we're about to run the fire test just so you know. This is not some quiet little beep in the cockpit. This thing is designed to be loud, chaotic, and impossible to miss.
And what's really cool is how they do it. It's a two-step process. First, they test the system that monitors the system. They're making sure the wiring that looks for problems is actually working. Once they know that's good, then they test the actual fire and overheat alarms for the engines. It's a check of the check.
And when that test happens, the cockpit just explodes. You get a loud clanging bell, bright red lights flashing everywhere, the engine fire switches themselves light up. It's a total sensory overload, and that is completely by design. Because all that chaos, that's a good thing. It means that if there ever was a real fire, there's absolutely no way the pilots could miss it.
Then comes another really dramatic test, the stall warning. A stall is a super dangerous situation where the wings lose lift. So how does the plane warn the pilots? It physically and violently shakes their control columns. It's called the stick shaker, and they test it on the ground to make sure that jarring physical alert is ready to go if it's ever needed.
All right, the safety systems are all awake and we know they work. Now it's time to tell the plane where we're going. And to do that, we have to talk to the brain of the aircraft, the flight management computer.
Pilots don't have a normal keyboard and mouse. Instead, they use this little guy, the Control Display Unit, or CDU. This is basically their keyboard and screen to program everything about the flight into the super powerful flight management computer, the FMC.
And they put in everything. They program the entire route, from the origin airport to the destination and all the little waypoints along the way. They input all the performance data, like the plane's exact weight, how much fuel it has, and most importantly, they confirm the critical takeoff speeds, the V speeds.
The first, and you could argue the most important speed, is V1. You can think of V1 as the ultimate point of no return. If anything goes wrong before the plane hits V1 speed, they can slam on the brakes and stop on the runway. But the second they pass V1, they are going flying no matter what.
Next up is VR, which stands for rotate. This one's pretty simple. It's the speed where the pilot gently pulls back on the control column, lifting that big nose off the ground and pointing the airplane towards the sky. And finally, you have V2. This is the takeoff safety speed. It's the minimum speed the plane needs to safely climb, even if, and this is the important part, even if one of the engines were to fail right after takeoff. These three speeds are the bedrock of a safe departure. So, the brain is programmed. All the systems have been tested. Now we're into the final preparations to actually get this thing moving away from the gate.
And this is when it all starts to feel real. The pilot gets on the radio and makes a formal call, just like this one. They're officially asking air traffic control for permission to start the engines and push back from the gate. The journey is about to begin.
Once they get that clearance, it's time for the before start checklist. They'll flip on the fuel pumps, which feed the engines, and they'll power up the hydraulic systems, which move things like the flaps and landing gear. And then they hit one very important switch, the anti-collision lights. That flashing red beacon on the plane, that is the universal signal to everyone outside. Stand clear, we're about to start these engines.
And here we go. This is the moment we've all been waiting for. It's that sound every passenger recognizes. This isn't just turning a key. It is a precise, carefully monitored sequence to bring a massive jet engine to life.
So, the pilot flips the engine start switch. You'll hear a whirring sound as high-pressure air starts spinning the engine's core. That's what they call N2. When that spin reaches about 25%, the pilot moves the start lever, which introduces fuel. You get ignition. The pilots are watching the gauges like hawks, making sure the temperature doesn't get too hot. Then, right around 56%, the starter automatically cuts out. The engine is now running all by itself. Then they do the exact same thing for the other engine.
The engines are running, the plane has been pushed back, the ground crew is clear, we are so close. There are just a couple of final checks that stand between us and the runway.
Yep, believe it or not, there's still 2 more checklists, the before taxi and the before takeoff checklists. This is where they configure the plane for the actual flight, and most importantly, they set the flaps. Extending those flaps gives the wing more surface area, which creates the extra lift you need to get a very heavy plane into the air at a relatively low speed.
And that's it. After all of those tests, all that programming, all those alarms and checks and procedures, the plane is finally, truly ready. Every single system has been triple checked, and this incredible machine is ready to fly.
Just think about that for a second. All of that incredible focus, all of that complexity and precision, and it all happens before the plane has even moved a single inch from the gate. Kind of makes you appreciate that view from 30,000 feet just a little bit more, doesn't it?